There's a different like process.
Am I recording? Did I click record? Did I do it? I don't know how to. Okay, fine. Jeez. Today's the 16th. So you'll see a new module pop up on Canvas. If you haven't been to Canvas lately, I changed it now so that when you go into the Canvas page, the first thing that pops up is just the modules page. I was taught the other day how to do that. So go into Canvas, it'll pop up. After today, you'll have a new module. It'll be called like linear equations and their graphs or something like that. So the last one, word problems, was super long. You know, it had like 30 entries or 20 entries. This one will be brand new. So it'll be up at the top for you if you want to go check it out. 16th. And today and tomorrow, we will be focusing on one thing, and that is slope of a line. And it is important that we acknowledge that a line is straight. You know, there are curves in mathematics. Different types of equations make curvy things, but a line by definition is straight and goes forever in both directions. And so what we want to master is the art of figuring out how tilty is a line. Does it go uphill? Does it go downhill? Is it steep? Is it flat? Is it straight up and down? There are all ways to talk about slope, and that's the focus of today and tomorrow. So first thing I want to talk to you about is just the basics of lines that go like this. Can we all agree that those lines, and I would put these in my notes, but you don't have to, but can we all agree that those are uphill? Let's agree on that first before we move on. You always got the couple kids in the batch who say, well, no, you could be downhill. And what you need to remember about math is that we're very left to righty people. It's what we do in math. And so as we travel left to right, then by definition, those are all uphill lines. Do you guys know what the slopes of these would all be? They're actually all positive. And so from this point on, what you need to know for me is that if a line looks like this, it can be steep, not very steep, middle of the road steep, I don't care. If as you go from left to right, it goes uphill, the slope will always be a positive number. And you might wonder why we need to know that. And you'll just know. When that pops up, I'll remind you. On the other side of things, I think, obviously, we have lines that go downhill. And again, a line can go super mega downhill like that. It can go barely noticeably downhill, or just ho-hum kind of middle of the road downhill like this. But those all share the characteristic of, as you go left to right, you are traveling downhill. What do you think their slopes all are? Definitely negative. And again, that'll just be something that I hope I just say it once and it sticks, but it's something that just kind of needs reminding occasionally. There are two other types of straight lines. What are they? Right, good. Mr. Manlove has worked with you well. So let's first talk about a line that looks like this. That line does not go uphill. That line does not go downhill. That line never rises. It never goes up. It never goes down. The slope of that line is 0, the number 0. You all came to me from Mr. Manlove. He has this thing. He likes to spell out the word 0 with a Z-E-R-O. I don't know why, and I've never actually asked him. But I'd be fine if you guys just want to write the number 0. Okay? But if that's something that you inherited from him and you just want to keep spelling out the word, you get down with your bad self. The last type of line is looks like this. And we call that a vertical line, right? So the blue line above it is horizontal. The yellow one is called a vertical line. And what is its slope? Right, it has no slope. So you can write it one of two ways. You can say it has no slope, or you may use this fancy word that the slope is undefined. And as we talk more about slope here in a couple of minutes, you'll, I hope, understand why that is. You cannot define the slope of a vertical line. All other slopes can be mathematically assigned a number based on the definition of a slope. Vertical lines cannot. So again, to summarize, before we start actually doing slope, uphill, positive, downhill, negative, flat, zero, vertical, no slope. Got it? Okay, so let me give you just a quick synopsis, and then I'm going to head over and I'm going to do some of my teaching today actually in Delta Math because it just works really easy. So if I did a line like this, and I just asked you to tell me one thing about the slope of that line, what would you tell me? It's definitely negative because as we travel left to right, we will be riding down a hill, right? And down a hill means always negative. So no matter what's about to happen, when I'm done, I'm going to put a negative on my answer because I'll forget sometimes. I get to talking about slope and I just forget. So here's how you find slope. Here it goes. I hope this is all old news to you guys. On any line, you want to find a couple of points, and we call those, generally, we want to look for what are called lattice points. That means on a graph, you want your point to sit where grid lines cross so you can identify his name. Try not to pick tweeners, the points that are awkwardly like lingering between a couple of crosses. So the crosses, we call those lattice points. Lattice. Like some of your parents have hung like lattice around your house. Same idea. So first thing you do is you pick a couple of lattice points, and then you're going to make a vertical line, and then you're going to make a horizontal line. And those two things have names. I know Mr. Manlove, he taught them to you. What do we call the vertical line? Do you guys remember rise over run? I assume you've heard that a lot of times. So the vertical line we call the rise, and the horizontal line we refer to as the run. And rise does not mean to go up. I want to be perfectly clear. Rise can mean up or down, and run means left or right. So how this little game works is you always want to make sure that you make a right angle right there. That way there, you're guaranteed that you're making a perfectly vertical rise intersecting a perfectly horizontal run. So let's say I was on a piece of graph paper and I counted down and I figured out that my rise was 4. And then I counted out my run and it was 6. It's like you're reading my mind. What would the slope be? It would be. And we're going to fix that in a second. And you might think I'm crazy, but I want you to watch how I write this here. I'm going to write this: slope equals 4/6. Now we're going to do a couple things to fix it. First off, bless your heart for getting really upset at me over there, because I say it's easy to get into the rise and run and counting and mathy stuff and forget, oh, it's downhill. Of course, it's a negative. So there's a couple things that I hate about my slope. Number one, I hate that we didn't put a negative, and I also hate what? Yeah, it's not reduced, right? So overall, the slope would be negative 2/3. And someone had a good theory earlier, something about something they heard in science class, but I have yet to come up in 27 years with a good answer to this question. Why do we use M? I honestly, I'm not really sure. But that's the letter that you'll use to represent the word slope, lowercase m. Got it? And that's pretty much that, guys. So there's a whole second half to this lesson that I'll get to in about 5 minutes. But for now, I'm going to hop over and show you what it's going to look like on your Delta Math, because I want you to be familiar with. We're finding slope graphically, and I'm going to zoom in a lot for you so that you can see what's going on. So it's going to ask you to draw a line representing a rise and a line representing a run. So poof, there's a graph. First thing that comes to mind is what? It's negative. And I'm telling you, if I had $1 for every time like perfectly smart people forget to put negatives, I could pay off my house. It's like, it's insane. So go into this just saying, I'm going to put a negative, and you can put it now, but we're going to find lattice points. And so I realize it's easier for me to see because I'm up a little closer, but you guys all agree that right here where I'm moving my mouse is a lattice point. Like you would not pick this point where I'm moving my mouse. You see, the computer won't even let me. It's like, no, don't pick ghetto points. And so I'm going to click right here, and I'm going to make a rise by clicking straight down. So what I did is I'm building the vertical horizontal staircase thing. And now I'm going to click on this point again, and I'm going to make my run go back like that. And I'm going to do my rise and my run. What is my rise in this case? What's my run? So what's my overall answer? -1/2. And what's, by the way, if you ever screw up and you get something you don't like, just click it and it'll go away. Let's say Adam had picked this point and then went all the way down like to here and then clicked this point across to here. Is it still going to work? Yeah, he's going to have more reducing to do, big whoop-de-doo, right? But like that one's going to be a 5 and a 10. Ooh, but it's still -1/2, -1/2. Got it? So let's see if I can find a new one. Same kind of idea there. How about this one? What do you see? Definitely positive. Okay. How about this one? Negative for sure. So again, you just pick any point and make a staircase. So like I could click right here and then drop and then click here, head across. Don't click your lattice points because then it's going to waste one of you. You only get to draw 2 lines and it'll keep giving you an error message. So the only click, 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 click is your rise line and your run line. So what would this slope be? What's my rise? Did I drop my pen or something? No, there it is. Yeah, so we all agree the rise is 3, I think, and you can call it -3 if you want to, but the rise bottom line is 3. You all see that distance right there is 3, and the run is 1. So the fractional value, sorry about that, the fractional value is 3/1. What does that really equal? And then, yeah, and then we just remember to put the negative on there, and that's all. So if the computer gives you a horizontal, you don't have to do any rise and run lines. You obviously just put 0. If it gives you a vertical, there'll be a little button for you to click undefined. Good. You ready for the second half of this? This is the reason I'm re-recording is because I did a real poopy job with this part of the lesson earlier. I brushed past it way too fast. So the other side of things, and I always like your input. Did Mr. Manlove, did you guys do these types of problems where it just gives you the numbers? So you know your slope formula already? The y2 minus y1 over x2 minus x1? Yeah, it can be intimidating because it looks like really harder than it is. Really, all it says is, hey, dum-dum, subtract the y's, subtract the x's. That's it. So we're going to practice. I have 6 of these that I want to practice together with you, and then I'm done, and you can work. Okay? All right. So I'm going to head back over. This is what your next set of problems will look like. I'm going to head back over here. And I chose these 6 exactly. So get these down in your notes along with me. So we're going to be finding slope now without a graph. So could I theoretically, if I were really stubborn, just always go and find a big piece of graph paper, graph the points, and do my little cute line trick? Sure. It's just not really practical. So here we go. The slope formula, and I don't really ever want to write this again because it's just, like I said, its bark is way bigger than its bite. The slope formula says that slope equals second y minus first y over second x minus first x. Those little numbers below are called subscripts. They're not like exponents. They're just labels. You follow my directions, you almost can't miss these. I mean, we're human and we all do funny things, but it's just impossible. Don't go rogue. You got this. Here it goes. So y2 means the second y coordinate, and the second y is obviously right here where I'm moving my pen. So what I like to do is draw arrows. And so I'm going to say, okay, 9 to the 5. Notice I connect the y over to the other y. And I'm going to write that as a subtraction problem, and it's going to say 9 minus 5. And then I'm going to put over, and now I'm going to switch colors, and I'm going to do the exact same thing. I'm not going to parallel that arrow, but from x to x. Don't go backwards. If your arrows crisscross, you're going to get wrong answers. So I'm going to go 8 minus 2. Now, pretty hard to believe that you could mess this up. I believe that this is impossible to miss. What's 9 minus 5? And what's 8 minus 2? And 4, 6 reduces to 2/3. Done. Any questions about that? So I say every one of these I've hand chosen because I believe they all serve a different purpose. So here's your next one. Here are the points: 1, 6, and 4, 4. So you got a line going through those 2 points. What is the slope of the line? The downside to this is that we don't have the visual. With a line, you have like a visual cue. If it goes uphill, I know what to expect. If it goes downhill, I know what to expect. So that's okay. This one's definitely going to be negative, right? For sure. Good job. So let's follow the arrows. Here we go. From here to here says 4 minus 6. And as long as I'm the guy up here with the pen, I will never skip that. So if you want to race ahead, you can shout out the answers. I'm not going to write them down. I'm always going to write the problem. And then I parallel that with another arrow and I go 4 minus 1. I'm always a right to left guy. You could do the other way as long as both your arrows go the same way. I've just always been a literal interpreter of the formula. And then you just do math. It's like second grade math. I mean, I feel bad saying that, but like you can't miss this. What's 4 minus 6? It is negative 2. And what is 4 minus 1? It is 3. And overall, a negative divided by a positive is a negative. So that would be my slope. Next one I have for you is this. First subtraction problem is negative 1 minus 5. And I say this with the utmost sincerity. I couldn't care less what the answer to that is. I'm just going to write it down. And now I'm going to head over to the yellow and go this minus this, which is 7 minus 7. Let's do the math. What's negative 1 minus 5? Negative 6. And what's 7 minus 7? And you guys have all been in Mr. Manlove's room. So somewhere on his wall, he has like the 10 commandments of mathematics, I believe. If you've ever taken the time to look, commandment number 1 is thou shalt not divide by 0. You know this. What happens when you try to divide by 0? It doesn't equal 0. You can't. If you have a calculator, get it out right now and type in something. Pick any number you want divided by 0, and I guarantee it'll give you an error message. It's one of the most basic tenets of mathematics is that you cannot mathematically divide something into 0 pieces. You can't. It's not defined. Therefore, when this happens and you do your slope formula and the bottom number is 0, your slope is not negative 6 over 0. Your slope is not 0 slope. It is undefined. Remember, we only say 0 when it's sideways. That's what I'm talking about. That's a nice segue into my next example. How convenient. So if I'm a good note taker right now, I'm writing this down. If the 0's on the bottom, it's undefined. There you go. Yeah. So again, great segue, whoever said that, to my next example. Let's look at 3, 8, and then the point negative 2, 8. Stay consistent with my color coding here. So my first subtraction problem is the red arrow, and that would say 8 minus 8. My second subtraction problem is the yellow arrow, and that is negative 2 minus 3. What is 8 minus 8? It is 0. And what's negative 2 minus 3? And what is 0 divided by negative 5? You can divide 0 by negative 5, and the answer is 0. 0 slope. That's what kind of line would that be? Nope. Nope. This is 0 slope. Horizontal is 0 slope, right? Vertical is the one above it that's undefined. Won't take long for you to get those stuck in your head. My last couple of examples serve a very different purpose. And honestly, this is the reason I'm re-recording is these two examples right here. I felt pretty bad about this. So thankfully, they're a pretty bright batch. They'll be fine. Here we go. This is where we really separate the A's from the C's and the C's from the F's. It's like, who's really willing? Who's in it to win it here? And I say that meaning don't skip steps. Here it goes. Red arrow is right there, and that says negative 1 minus 9. No big deal, right? And then I go over, I'm going to switch to yellow, and I want someone to read to me out loud what that subtraction problem says. Yeah, I see you've done this before. You guys are amazing. Yes, what it would be quite literally is 1 minus -4. You guys have been taught well. And then the minus and the negative come together to create an actual addition problem. So this is really saying 1 plus 4. You guys are good. What do we get on top? What do we get on bottom? And what's -10 divided by 5? -2. And don't put -2/1. I appreciate the sentiment, and that would be pretty rad if we were trying to graph it. Like I would love to see the down 2 right 1, but for the purpose of just saying what is the slope, -2 is what we. All right, one more, guys, and then I think I'm probably done with you, and you can have the rest of the hour to hopefully get your assignment done. All right, let's do this. We are consistent. I've always lived in a world where we shouldn't miss slope, ever. The top says -8 minus -2. And as I said, minus negative, I used the minus for the sideways, and then I crossed the minus with my negative like that, right? So minus a negative became plus, and then this one is 5 plus. So if you watch my pen, 5 minus -3. Cool. What's -8 plus 2? What's 5 plus 3? What does that reduce to? -3/4. Nice. What you'll find in today's assignment is a mixture. It's not, I know sometimes I have you do like 10 of these and then 10 of these. I asked Delta Math to take 30 problems and mix them. So some of them will be the graphy kind where you do the little clicky lines, and some will be the mathy kind. And they'll just random order, random problems. You get what you get. That's what it is, right? All right, get her done.